Hello, we are here for one more lesson of this SprutCAM training course in video, and today our lesson will be called Basic Technology Terms. This has a lot of different topics, so to avoid to have very long videos, we will split this group in 4 lessons, and today we are going to talk about some topics that consists of part 1. So starting with this, I've opened and I'm using a model that you know already from previous videos, but I think it's very good to show what we need about today's topics. First topic is called the part. So the part is, in our example, is a group of the geometrical elements that define what we want to machine. So in our example, it is the CAD file, this part here, the model. Then we have something called the job assignment. The job assignment, which we can define in this icon here. So job assignment. In our case, it is empty. But this topic defines the surfaces and the areas which we want to machine. So instead of having the complete set of surfaces to be machined, we can isolate and define particular jobs with particular areas. So simply job zone, and we could define with a couple of parameters. We could, for example, go to edges, surfaces and meshes, and for example define a couple of surfaces which I don't know which one are these, and simply go and say add. So we have some mistakes because I'm not paying attention to some details, but this is to show what we can do. So simply, and now we have the mistake which does not want to go out. Okay, now it went out. So we can choose a couple of elements and define a particular area to apply our milling toolpath. Then we have another important topic called the workpiece. And in our example, you can see the definition of the workpiece as this transparent box. The workpiece is what we define as the start of our calculation. So for the example, when we start to mill this part, we have a block of material which we want to define as the base to calculate our toolpath. So it will make a rough toolpath to start from a rough block of material and to start defining a shape. So we can also define a couple of interesting stuff for this workpiece. We can start defining in a very different number of ways, but I would say in our example, this primitive is the best one, where we can define, for example, a box in some different parameters and with dimensions. So because our initial block of material can be bigger or a little smaller, or with some areas that are not so good, and we want to approximate or at least exceed a little the dimensions of this block of material. So we can do this for many different reasons. Then we have another concept which is connected to this workpiece. When we do one rough toolpath, in this case a waterline, then we apply the toolpath, we calculate a toolpath, and we will have this kind of result, which is a block, not as a box for the second toolpath, but already with some definition, like the one that is shown here. So we have a concept that is called the rest machining of the remaining material. And when we will apply the second toolpath, when we will calculate it, we can do a workpiece of the previous operation. So instead of going through empty areas where there is no material, the the calculation will take in consideration only the material where it is. So it will have some attention to these areas where are a little more excess of material, and it will optimize the passes and the time spent doing the toolpath. Another topic called fixtures, so defined it here. The fixtures are these items, which we can define also in a number of ways. In this particular case, we imported the elements inside and defined them as fixtures. And these fixtures are defined so that SprutCAM uses these as areas which cannot be touched because they are not they don't belong to the part we want to mill. Then we have something called drill points, and the drill points, especially for the roughing toolpaths, are very important because on the point where the toolpath or the tool needs to enter, sometimes it is always good to start from a position outside of the material, and entering in the material to avoid problems of breaking a tool or something. So we need to come outside, but in some particular areas or in some particular configurations of this workpiece, maybe it is more interesting to enter in the middle. And to help these problematic areas, we may need to define a drill point that is previously drilled, as the name says, and we can define these drill points somewhere. Where are they? This one. Holes, so we can recognize geometry if needed. So it's not the case. We don't have anything defined. But we can also apply it on the center if possible, or simply create a point giving some coordinates and some parameters here for the diameters and depth and so on, and we can define that as a drill point. So the tool will enter on that point knowing that on that particular area there is no material, and with a safer way to enter the material. Then we have tools, and we have different kinds of shapes for tools that we can use in SprutCAM. We have different shapes for milling and different shapes for turning. We have this possibility to change the shapes, but in this area we cannot see the shapes. So we click on the toolpath, we go to tool, and it is easier to see them here. So tool group, cylindrical, spherical, and you can see the shape changing: torus, double radius, and so on, conical. We have a lot of different shapes, each one of the shapes with different types of parameters to define the dimensions, but the idea is to know that we can have these different shapes which are important. With the shapes and with the definition of the tool, there is one important concept also, which is the overhang. And the overhang is the distance that we have from, it can be defined in different ways, but basically it is a distance from tool base point to tooling point. So tooling point, or the point that contacts with the part, from or until the point that is outside of the tool base point. So it is this distance that will be defined as height, and we can define it to calculate collisions. So we can do it through this point here. It depends. There are several examples in our theoretical side of this course for situations in terms of milling and in terms of turning, because this can be defined in a couple of different ways. Another point, another topic, sorry, it's the tool movement areas. So we have different types of movements, which we will try to define here. For example, in this roughing toolpath, you can see that we have different kinds of lines, and we have these kinds of movements from a higher point to this point here, and then we have different movements to where we try to go closer the part, and then these movements around the part. So these all of these movements have different things, different names. We can try to calculate also this one. In this kind of toolpath, we have different types of movements also. For example, this type of movement where the tool comes from one area where it is creating the part to move on to the second pass. So different things. A couple of names. So we have what they call approach, and the approach, it is what we can define as what it means the path that the tool takes to arrive at the first point of an engage. We have the engage. The engage, it is the point when the tool goes to touch the material. Then we have something called working tool path, which is in fact when the tool is in contact with the part. Step over in this roughing tool path, it is from one level to another level. It is sorry, I'm saying it wrong. The step over, it is this distance from one pass to the other pass. This is the step over. In this kind of tool path, the step over, it is this distance from this line to this line. It is the step over. It is different because the tool is also different. And then when the tool goes out of the material, it is the return. We have different kinds of things. We can define them all. So for example, lead-ins, lead-outs, and in parameters also we have all these parameters around. We will need to see them a little more in detail. Feeds and speeds, because all these previous movements have different purposes. We can define feeds and speeds for each one of those. So work feed, we have a couple of parameters. If we go to approach, we can define other type of parameters, and you can see also the graphics changing here, the retract, different ones, the plunge, and so on. So we can define all of these parameters in terms of feeds and speeds. One interesting concept also, it is the safe plan. Safe plan, it is in this toolpath, it is this horizontal plan defined as a place where the tool can move without the risk of touching anything. So we should define a height safe enough, but not exaggerated to lose time, but safe enough above whatever it is on the tool table. And we have this Z retract height. We have also a couple of where it is the safe plan. In this particular case, it is this level here, which we can define where we want. We have also another concept, for example, when we are doing this kind of toolpath, the roughing or anything that it is done in levels, which it is this kind of toolpath, or the level finishing, where we can define also top level and bottom level. So we can say to the system, work only exclusively in between these levels here. Okay? So it is a very interesting topic also. Besides, we have also a concept that we call the tolerance, which is this deviation to the outer or to the inner side of the geometry. And this is what the system allows to deviate from the shape. So we can go 0.02 out of the shape to simplify a little the shape and the size of the program. So this is one of the parameters that definitely influences the time and the quality of the final tool path. So we can use it a little careful, because it will have that very important influence in the result. Finally, we have something called the stock, and the stock is also defined here. The stock is an excess of material that we can leave on the part, and we have different types of stock. So in our example, and graphically it is shown, the axial stock and the radial stock. So we can leave for safety or for other purposes, for example, instead of 0,0, which means that it will respect fully the shape. We can say, for example, leaving a couple of material here, 1 millimeter in the case, and I say in my plans I will leave only 0.2. So it will have that also in consideration. As we are saying and defining a roughing toolpath, it is desirable that we leave some material for the semi-finishing and the finishing toolpaths. You see also under finishing, we have also deviation and we have also stock. In this type of program in particular, the stock is only one, because it will have a different type of movement on the part. So for this first lesson of these technology terms, these were the topics that I had in consideration to mention in the video. For more details about all of these topics we spoke about in the video, you can ask us for any help if needed, but you can also consult our theoretical side that we have available inside our online platform called Area 51. If you are interested, ask us for more information on how to assess it.